Hey guys, welcome. 3.8 video. Boom, right there at the top, slopes of parallel and perpendicular lines. So we're going to relate the slope to parallel and perpendicular lines. We talked about in our last unit about, or not last unit, last lesson about slopes, and we talked about equations of a line. Now we're going to get into particulars of the slopes of parallel and perpendicular. Remember, parallel never meet, perpendicular are going to meet at a 90 degree. So let's go ahead and get to it. Okay, so everything that you see here you're going to write in. I think it takes up like the whole screen pretty much, but slopes of perpendicular lines, I always like to highlight these top parts and then bullet point these underneath. So two non-vertical lines are perpendicular, then the product of their slope is -1. Okay, so two perpendicular lines, if I were to take their slopes and multiply them to each other, I'd get -1. If the slopes of two lines have a product of -1, then the lines are perpendicular. That's pretty much the same thing. Any horizontal and vertical line are perpendicular. Okay, so write all of that, and then let's take a look at slopes. Two non-vertical lines are parallel, then their slopes are equal. So if you have parallel slopes, then they're equal. If the slopes of two non-vertical lines are equal, then they are parallel. And then any two vertical or any two horizontal lines are parallel. All right. Notice something real quick, and I'm going to have you write all this down, but this statement versus this statement, they're just the converse of each other. Notice it's a if-then statement. If parallel, then equal slopes, and then we flip it. If equal slopes, then parallel, and they did the same thing with the perpendicular ones. So do keep note of that. If you have one, then you have the other, and vice versa. Okay? Let's get into a couple examples. Example 1, make sure you draw the picture and you write this out. Otherwise, no notes credit for you. Okay? So how can I tell if lines are parallel? Well, they look parallel. That is not a sufficient answer. So we have to actually find the slope. Remember, always start at the furthest to the left, and then we're going to go to this one over here. So I'm going to go over 1, 2 units. So I have a run of 2. So I'm going to call, this is line 2's slope, and the 2 is the run. Then I'm going to go down 1, 2, 3, 4, 5, 6, 7, down 7. So that's the slope of one. Let's look at the slope of the other one. Okay, again, start at the left. I go over 1, 2, 3. So I have a run of 3. And I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 9. Okay, are those slopes the same? Well, we should probably reduce them if we can. This one can become -3. But these two slopes are not the same slope, so not parallel. So line 1 is not parallel to line 2, and because they don't have the same slope. If they had the same slope, we'd be good, but we don't. Alright, let's move on. Okay, what is the equation for the line parallel to y equals -3x minus 5 that contains -1/8? So this is problem 2, make sure you write it out. Okay, well the word parallel means we're going to have the same slope. Okay, same slope. So all I really have to do is take the slope out of this line and use it with this point. And last time I checked, we have an equation that's called point slope. So we're going to go ahead and use point slope. I'll give you point slope on the test, but always good to write it out. And we just plug in what we know. I'm going to label this x1, y1. And we plug in -3 is our slope, x minus a -1, that becomes a +1. It always looks different in the equation when a negative's built in. And then y minus 8. Boom. Just like that. Boom, boom, boom. Could you solve to make it look like it's in y equals mx plus b form? Yeah. We distribute the -3, so we get -3x minus 3. And then all we would do is go ahead and add the 8 over. And we get y equals a negative 3x plus 5. Okay? So either one of those would work. Okay? Let's continue. Okay, this will be our last question, number 3. What is the equation of a line perpendicular to y equals 1/5 x plus 2, and it contains the points? This is the exact same problem as the parallel one, but instead of the same slope, we said that the products equal -1. Okay, well, the only way you can get products equal -1 is by using what's called the opposite reciprocal. So we need to have the opposite reciprocal. Okay, so we have a slope of 1/5 and we have a point right here. So we can put this into this equation of y minus y1 equals mx minus x1 and all that good stuff. But what's the slope? It's not going to be 1/5. If I put 1/5 in, that'd be a parallel line. I want the opposite reciprocal. So what I'm going to do is I'm going to do the opposite sign. So instead of a positive, so we have 1/5, the opposite reciprocal is going to be negative. And then reciprocal means we're going to flip it. Okay? So instead of 5 on the bottom, we get 5 on the top and 1 on the bottom, which means the opposite reciprocal of this is just going to be -5. So I'm going to plug in -5. And if you multiply -5 times 1/5, you're going to get -1. That would be the product. We plug in x minus here 15 equals, and this is going to be y minus a -4, which is going to make it positive. And I'm not going to solve this one for y equals mx plus b form, but we could. And that's it. So opposite reciprocal, we change the sign. If it's negative, then it becomes positive. If it's positive, it becomes negative. And then we flip it. Whatever it looks like, we flip it. So if 5's on the bottom, then 5 goes on the top. If 1's on the top, then it goes on the bottom. Okay? All right. Toodles.